times x, so that's my product rule, equals 0. Is what we want in this equation? Yes. Do you know everything else? See, now you can fix it. Now you can fix the point in time. Y we know is going to be what? 2, so I've got that one. dy dt I know is -3, and x is going to be 4, right? So I've got them all. So it's just a matter of plugging in now. dx dt, bless you, times y, which is 2, plus dy dt, which is -3, times x, which is 4, equals 0. You should get dx dt equals 6, right? -3 times 4 is -12. Move to the other side. 12 divided by 2, 6. 6 what? X is our measurement, right? It's in centimeters here. Per time, and here is seconds, right? And it's positive, which means it's moving in which direction? To the right. Which corresponds to our graph, right? It looked like that? It was coming down like that? If it's saying if it's coming down that graph at a certain rate, in order to stay on the graph, it's got to be moving to the right at a higher rate. Because what's happening is it's flattening out as you go to the right. Like it's getting, so the further down you go, the faster you have to go to the right. What's your feeling on this, everyone? I mean, I'm really not quite sure how to read your demeanor right now. All right, let's look at 14. This will be the last one I do. Although, in my videos, did I do a guy walking away from a pole? I did? Okay, let's not do that one then. Let's do something way different. Did I do the boat being pulled into the dock? That one's kind of lame. All right, let's look at 17. A man starts walking north at a rate of 4 feet per second from point P. So I'm just drawing pictures now. Here's point P. This guy starts walking north. He's walking at 4 feet per second. He's walking north. 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 feet due east of P. So what should I draw here? Horizontal line to the right would be east. Oh, man. Was it 500 feet? And she starts walking due south at the same speed, right? No, she's 5 feet per second, sorry. She's going down like this. Yes? At what rate are the people moving apart 15 minutes after the woman starts walking? Okay. Does anyone notice something right away that we need to address before we get too deep into this problem? Okay? We might have some triangle stuff going on here, but even before that, they tell you how fast the man's walking, right? The man's on the left. So the man, oh, isn't this the symbol for man? What is it, the arrow? And then the woman's over here like this. Okay? The man's walking 4 feet per second, the woman's walking 5 feet per second. But she starts walking 5 what? 5 what? That's right. The measurement of their speed is in feet per second, but they're giving us the time for how long between when they started and stopped and stuff in minutes. So we've got to get everything in the same unit before we can continue, right? So the first thing I'm going to do is this. I'm going to reword the problem. Okay, she starts 5 minutes after him, right? Woman starts 5 minutes after him, after the man. I'm not looking at the problem. Is that what I said? Okay, 5 minutes. Screw the 5 minutes. 5 minutes is actually how many seconds? 300? "300 seconds after the man," right? Then she starts walking, right? And at the moment that she's what? At what rate are the people moving apart 15 minutes after the woman starts walking? So 15 minutes after woman's walking, woman starts, really means what? 15 times 60 is what? 900 seconds after woman starts. Which is actually also what? 1,200 minutes or seconds after what? The man starts? It's actually 20 minutes after he started, isn't it? Like he starts walking, he walks for 5 minutes, she starts walking, 15 minutes later, boom, at that instant, how fast are they moving apart from each other? That's relative to the man, it's 20 minutes later. To her, it's 15 minutes later, right? Just keep that in mind. Now let's try and draw a situation for the instant in time and the general situation. Instant, general. These pictures are going to look pretty much the same. In the general picture, can I keep the 500? Yes? Okay? Now, at the instant in time, 15 minutes after the woman starts, that's 900 seconds after she starts. That's 1,200 seconds after he starts. How far has he gone? 4,800? How fast does he walk? 4 feet every second. How long has he been walking? 20 minutes, which is actually 1,200 seconds, right? Right? Do y'all understand what I'm saying or no? I mean, he's been walking for 20 minutes, which is 1,200 seconds. 1,200 seconds. Every second is 5 feet. 5 feet? 4 feet. 4 times 1,200 is 4,800. Yes? So we know this is 4,800 feet. How far has she walked? So she went 5 feet per second. She only walked for 15 minutes, which was 900. So 900 times 5? 4,500. Now, in the middle, was it 500 feet? Okay. Good thing they didn't say like 500 meters, because then we would have to convert meters to feet, wouldn't we? Would I do that to you on a test? I wouldn't do that to you on a test. What do you mean formula sheet? Yeah, your cheat sheet has all those pictures. Yep, you can have that. All right, the general picture now. Yes, but I need something here. I need to label this. I mean, could I do this? At some point in time, hasn't he gone a distance x? And at some point in time, she's gone y? Right? That's just the general scenario. He's walked some distance, she's walked some distance. If I fix the time, right, if I fix it, then I actually know how far they've gone. But in general, it's x and y. Is that all right? Do y'all want to do with that? Do y'all want to do it that way? Now don't scratch out everything. You can do these different ways. Okay. There's different approaches to these problems, so is that all right though? Okay. What is it that I'm given? What is it that I want? Let's try this, see how far we get with it. What is it that I'm given? What is it that I want? Do what? Set it up as a triangle. X and Y together. What do you mean X and Y together?
Add them together. You have to move the second string. The X and the Y would be the height of the triangle. The 500 would be the base of the triangle. Trying to find that height.
I'm not sure I see.
X and Y just become the Y and the 500 X.
But hold on a second. The distance between them, we want to know how fast the distance between them is increasing, right? Isn't the distance between them the line connecting them right there? Isn't that the distance between them? Yes? But that's the hypotenuse of what triangle? That's what I'm trying to figure out. You're saying it, which one though? It's two hypotenuses. Yes, okay. That's what I'm asking you. How are you making one triangle out of that? I see what you're saying now. I see what you're saying. Okay. I see what you're saying. But I'm still waiting for us to go through this procedure because what's given, what do we want? You're given how fast they're walking, right? So in terms of our variables, I know dx dt is how fast he's going, right? And he's walking up, right? So he's going up, which means dx dt would be what? Positive. What's his speed? 4. I'm also given dy dt to be what? 5. Yeah, the question is whether or not it's going to be positive or negative. Well, they're walking away from each other, aren't they?